Hello, everyone. This is going to be likely our last little unit on in terms of Math 8 stuff. And this unit's going to be a bit heavy. And we're going to talk about just graphing and some basic algebra and polynomials. So let's first talk about graphs and characteristics of graphs. So before we get into that, let's talk about three terms that when we refer to as an average. So what is an average? An average is, well, we can interpret as the middle term of a whole set of numbers. The average height, the average income of a place would mean different things in different contexts, but let's define it more specifically. So we have three definitions of it. One is a mean, second is a median, and third is a mode. So let's get a set of numbers. 1, 1, 3, 7, 9, 11, 13. So before we get into the mean, let's talk about the median and the mode. The median would be equal to, let's say, organizing the numbers from biggest to smallest in order like this and picking the middle number. So 1, 2, 3, 4, 5, 6, 7. So as you can see, we have three numbers here, three numbers here. The middle number will be 7. So the median for this set is 7. And this would mean like, hey, this would be our average median of a population would be 7 in this case. You can imagine this, maybe it's different. Like this is like the amount of money everyone in the class has for lunch. And the two people with one is a bit, it feels bad for them. But anyway, the mode is the number that shows up the most often, the most number of times. So one shows up the most, shows up twice here, and all the other numbers only show up once. So mode would be 1. And the mean would be if you add up all the numbers together and you divide it. Divide it by the number of numbers. So I'm just going to do this in my head. 9 plus 11, this is 20. This is 10. So this would be 32 plus 13, and that's going to be 45. 45 over 7. So our mean is going to be 45 over 7. 45. I'm not going to simplify it, but this is just something you should know. Just add up all these numbers, divide by 7, which is the number of numbers that you see, and this is going to be the mean. So different, you'll use these different terms differently when we're dealing with statistics or when we're looking at data and we want to learn something from it. Because let's say we have a population of people. I'm going to just graph it out. Let's say this, let's just talk about graphs now, actually, because I think this is a good place to branch into it. So on the X number, let's say it's income. Income of a population, how much money a household in household income might look like. So income can range from $0 to $10,000. I'm gonna instead of writing 10K, I'm just gonna say this is in units of thousands of dollars here on the x-axis. We have 10, 20, 30, 40, 50, right? This could be just the frequency or the observation frequency, and this is y, which is like the number of people that number of households that we see that have this not have this amount of money. So a possible case that can happen is if we see a lot of people having very little money in the household, and then it goes down like this. Maybe it grows a little. But then once we hit the high income earners, well, we have a lot of people who make a high amount of income and also a lot of people who make not much income compared to the middle value, right? So in this case, if we were to use a calculation of mean, it's possible that it's difficult to find someone who is actually right in the middle. It's difficult to find a household in this country that's in the middle. It's difficult to say that that is representative of this population. Because when we're trying to use an average, we're trying to say like, oh, hey, what is by chance, if we take someone from a data set from a random number, what's the most greatest likelihood of being representative of the data set, if that makes sense. So, and obviously we're not going to take mode. Let's say the mode is, let's say this higher income is actually the mode. Then if we were to take the mode and say that the entire population, the average of the population is a mode, then it's difficult to understand. Like, that makes no sense, right? Because obviously you can't say that everyone is rich or the average person is here when there's so many people here. And the median is for other reasons. But another case is, let's say we have a skewed population. Like imagine, I'm not going to draw it out, but imagine this is still income and frequency. I'm not going to add in the numbers, but let's say they have something where people are really high in the middle, but they drop out from both sides. Now this time mean would kind of work well because okay, where we are, the average number, the average in the middle is actually the value. And median was also work out because as you can see, the middle value is representative, a very representative of the range of the population, and so the mode. But there's a case where, let's say, instead of everything, let's say we have a giga-rich class, like a giga-rich class of world elites here. Well, the issue now is if we were to calculate the mean, it would skew this end, and it'll say that the average is here, because now that we add this entire all these numbers of really rich people, the calculated mean is going to skew this way, whereas the median wouldn't actually change that much. Why? Because the median is based off of positioning. So based off position, not it's not influenced by the actual adding of significant amounts of numbers. And the mode will change a lot because it shifts here. But there can also be a case where, well, I'm not going to explain any other cases, but because this is just for you to understand. It's not for actual any practical purposes. But this is just some ideas. And now that we gotten this done, we're going to start talking about linear relationships. So, linear relationship is a relationship that if you graph it on a graph, you can say it's linearly. Let's say eggs at the supermarket cost $7 each. So or like $7 per box, right? A box, a dozen eggs or whatnot. Let's say if I buy one box of eggs, this is going to be equal to $7. Well, I get two box of eggs. Well, 7 plus 7, that's going to be 14. Let's talk about it here, 14, right? And so on and so forth. And then a third is going to be 21. And if you graph it on a graph like this, you can get a relationship where you can draw a line through it. Now, this is going to be a relationship as stated in the name. I shouldn't use a number 7. I should use something 3. Let's say a cookie is $3. So we can first draw it on a table, X's and Y's. So let's say we don't buy any cookies, then we're not going to get any cookies. We're going to get one cookie, then it's going to be $3. Two cookie, $6. Three cookie, $9. Four cookie, $12. And now when we graph it out, zero cookie is $0. One cookie is going to be $3. Two cookie, $6. Three cookie, $9. Four cookie, $12. This is a linear relationship. And you can understand, and you can also do the reverse. Let's say you get a number of points on the graph. You can look at the slope, also known as rise over run. So what the slope is, you're saying, okay, how much does this go up in the y-axis versus x-axis? So slope, we also express this as m equals change in y. Delta is a symbol meaning change over change in x. Rise over run. Run is on the horizontal axis this way. On the x-axis, rise is going to be on the y-axis, like going up. So yeah, if you look at the difference between them, you can find the slope and extrapolate it this way. Now, another thing is maybe there's an initial value here. Let's say you have to go to the cafeteria, but just going to the cafeteria, you need to pay $2. I don't know why. It's a $2 cafeteria that you need to pay, and then every cookie is $3 after that. So what this does is it's going to shift the graph a little bit. When you have no cookies, you're still going to have to pay a $2 fine. It's your problem. You buy one cookie, it's going to be 5. You're going to spend $5 because it's $3 on top of the 2. 2 is going to be 8. 3 is going to be 11. So now that you have this graph, we can graph it out. A 0 is going to be 2, and this is going to be 3, or 5, 8, 11. Let's go look like this. 1, 2, 3. So this graph, the m is going to be this, but what this value here that's being shifted on the y-axis, the 2 that we just added, this is going to be called b, or the y-intercept. So the y-intercept, you can find it when x is equal to 0. When you set x is equal to 0, you find the y-intercept. Similarly, when you put y is equal to 0, you find the x-intercept. This doesn't really apply here, but this would mean a negative value. This would probably mean like -1 or something. So it's like saying, let's say the cafeteria owes you a trip to the cafeteria. They're going to owe you $2 now. This is kind of impossible in this situation, but we just need to know the intercepts. But for now, just know the y-intercept at least. And the yb is going to be equal to 2 in this case, which you can understand from looking at a graph. The big idea is if you look at a graph of points and whatever, you should be able to understand that this value is going to be the y-intercept and it's going to be b. Now, putting all this together, you're going to have to create and draw graphs this way. So the standard formula for a linear graph is y equals mx plus b. And let's use our initial example, or the $3 cookie, or the $3 cookie and the $2 entrance fee. Because we found out that m is going to be rise over run, which is $3 increase for one cookie. It's going to be 3 times x. And let's say the entrance fee is $2. It's going to be b of 2, so 3x plus 2. So what does this formula mean? Y is going to mean the cost, and x is going to mean the number of cookies. This is where we're going to jump into basic algebra. When you plug in a number for x, you're going to get a value for y, which is the cost at the end. If x is equal to 3, meaning buy 3 cookies, y is going to be equal to 3 times 3 plus 2. This is going to be 9 plus 2 equals 11. So the cost is going to be $11. This is just the formula that we use to express what is shown on the graph. Does this make sense? You also need to understand if we see this formula, can we transform it into a graph? Let's say we have a formula that says y equals 4x plus 1. What would this look like? When x is equal to 0, we can plug this in. Y would equal to 4 times 0 plus 1. Y would equal to 1, because anything multiplied by 0 is 0. So let's plug this in. It'll be 1 here. And then when x is equal to 1, y would be equal to 4 plus 1. This is 5. When x is equal to 2, this would be 4 times 2 is 8 plus 1, and that's going to be 9. So you're going to have to draw this out yourself as well. What helps is drawing a table like this. So as we can do this again here. When x is equal to 0, it's going to be 1. Equal to 1, it's going to be 5. 2, it's going to be equal to 9. And we can just graph it out this way. You can also graph the negatives and graph it out the other end, but that only applies in certain situations, right? So I think there's gonna be a lot of questions about stuff like understanding how these work in word problems. But let's just go over some quick algebra first. So you're going to be tested on a lot of algebraic equations. So a couple things you should know is some principles of algebra. If you're having 5c equals 25, anything time you see an equal sign, you can understand whatever you do on one side, you can do on the other. So if you add 1 on this side, you can say it's also equal to this. But let's say you subtract 1, just remove it, it's still 5c equals 25. Similarly, if a teacher wants you to, let's say, solve for c, you can divide both sides by 5. C would be equal to 5. This is just simple algebra and stuff. I'm not sure if you guys should already know this, but this is just something you guys should keep up with. There's also stuff you should know, like let's say if you want to solve for 7x minus 19 equals 33x or something, or yeah, something like this. What you have to do is you should put all the like terms on one side. So let's say you minus 7x on both sides, which you're going to get as negative 19 equals 26x. If you want to solve for x, we want to isolate it, so you have to divide both sides by 26. X will be equal to 19 over 26. This is how you would solve it. This is another principle you should understand. Another idea is, let's say, you got 5x plus 8 equals 68. Let's say you want to solve for x, subtract 8 on both sides. You have 5x equals 60, divided by 5 on both sides, and x is 12. So these are just some algebra rules you should probably understand and some basic equations. There's also some harder ones you can probably do for grade 8 math. Negative 2 over 9 equals 5 over 9p minus 7 over 9. So this is what we have when we did our first unit on, or our second, a couple of units ago on fractions. We want to isolate p. We have to first, let's move the 7 over 9 on this side. Think of it as like a portal. Whatever is negative on this side is going to be positive on the other. So we can add 7 plus 9 on both sides. First, get rid of this. And what we're going to get is 5 over 9p. It's equal to negative 2 over 9 plus 7 over 9. Remember our unit on integers and positive and negative numbers? So negative 2 plus positive 7 will be equal to 5 over 9. So 5 over 9p is going to be equal to 5 over 9. If you multiply both sides by, or divide both sides by 5 over 9, or multiply both sides by 9 over 5, you can cancel these out, and you'll find that p is equal to 1. So that's how you solve it. Just do more practice of these, and you can probably review some of your algebra stuff you learned in grade 7, and you'll be on a very good pace to finish grade 8 math. Hope you enjoy the video.